Hey everybody, this is Mr. McKee with Net225. Today I want to go over the packet tracer 7.2.10, which is configured DHCP version 4. Alright, if you look at my workspace for packet tracer, I've got my topology. The way this is set up, R2 is our main, is our edge router going out here to the internet. Alright, it has 2 gigabit connections, 2 serial connections. Alright, our network overall has 3 LANs. The 192.168.20.0 network, the 10.0 network, and then the 30.0 network. Okay. All right, so looking at the address table, R1, which is the bottom left, you got gigabit 00 and 0000 interfaces. Let's see if I can click on these. All right, there's 0000, there's your gigabits. All right, I'm going to skip router 2 for a second. Router 3 gigabit interface down here. All right, serial interface up here. All right, PC1, PC2, those are both going to be dynamically assigned by our DHCP server. All right, DNS server is over here sitting on our 20.0 network. All right, here's the interfaces for that. It's going to get kind of strange looking. There's our 3 interfaces for gigabit R2. All right, so R2 gigabit 00 is going to the S2. I'm just going to call it the S2 network. Gigabit 01 is going out to the internet, to our ISP. And if you see right here, we're going to receive an IP address that's DHCP assigned by our ISP. All right. And 2 serial connections are going to, let's see, this one's going to the R1 network. This one's going to the R2 network. All right. We've done round 3. PC1, PC2 dynamically assigned, so they don't have IP addresses right now. DHCP server, it's static. All right. All right. So that is about it for the overview. Now, just to let you know, this is pretty common, dynamically assigning an IP address to one interface on a router. Say if your home internet routers, like DSL or cable modem or whatever you have, fiber, your interface coming in from the internet ISP is probably going to be dynamically assigned by them. All right. If you get a static IP address, it's usually you have to pay a little bit extra for it. Don't really need it unless you're setting up like a web server, and you can have that dynamically change. But just understand that this isn't like out of the blue. This happens all the time because obviously that the ISP only has a certain number of IP addresses total, so they only want to give them out to people that need them. All right. So let's see a scenario. A dedicated DHCP server is scalable and relatively easy to manage, but can be costly to have one at every location in the network. A Cisco router can be configured to provide DHCP services without the need for a dedicated server. As the network technician for your company, you've been assigned the task of configuring a Cisco router as a DHCP server. In our case, router 2 is going to be the DHCP server for everybody. You are also required to configure the edge router as a DHCP client so that it receives an IP address from the ISP network. So R2 is our edge router, then also this interface is a DHCP client, and it's going to be assigned an IP address from this network. All right. So configure a router as a DHCP server. Configure the excluded IP4 addresses. Addresses that have been statically assigned to devices in the network that use DHCP must be excluded from the DHCP pools to avoid errors associated with duplicate IP addresses. In this case, the ISP addresses of R1 and R3 LAN interfaces must be excluded from DHCP. In addition, 9 other addresses are excluded for static assignment to other devices such as servers and device management interfaces. So you want to exclude your interfaces for your routers, your SVIs for your switches, servers. We want those to all be statically assigned. So the way this works, um, you don't set up a DHCP for Cisco equipment and just say I want this network to be my my DHCP range. You set up, it automatically assigns the network, whatever's on the network, it's going to assign all those IP addresses it can, and then you go through there, exclude whatever addresses you want to exclude from that DHCP complete range. All right. So in our case, like 192.168.10.0, it would be able to assign 254 possible host addresses, because that's, you have 256 possible addresses. One is your network address, one is your broadcast, 0 is your network, 255 is your broadcast. Same for these other ones that are \24s. But then you want to exclude out whatever IP addresses will be for your switches, routers, and servers. So 10 is a good number in our case. All right, so we're going to go to R2, because R2 is going to relay, it's going to send IPs to the other routers, and then directly assign addresses to this interface or this network. All right. So if you see right here, you're getting some log messages that say that you have EIGRPs installed already. That's fine. Enable. Let's do a show run. All right. Host names assigned. Passwords encrypted. Interfaces. Gigabit 00 is already assigned an IP address. Gigabit 01 is not, because it's like that one right there that's red. All right, interface serial 000 and 001 have IP addresses assigned already, and clock rate set. All right, we do have an EIGRP already set up. We're not going to worry about that right now. All right, and that's about it for that. All right, so let's go over here and actually configure our exclusion range. So config T to get in global config, and then IP space DHCP space excluded address. I tabbed over, auto-filled in that 192.168.10.1. So 10.1 is going to be our first excluded address, all the way up to 192.168.10.10. And let me make sure I typed it in right. All right, so that's good. All right, so configure R2 to exclude the first 10 addresses from R3. I was about to cough. All right, IP. Well, let's do, you know what? Let's up arrow, and all we got to change is the R3 network is 30.0, so 30.1 to 30.10. Okay, that should be good. All right, let's just go here, hit enter. All right, we're good with that. All right, so create a DHCP pool on R2 for the R1 LAN. Create DHCP pool named R1 space LAN. Make sure it's case sensitive, so make sure you have your uppercases the way it's supposed to be. All right. So we're still on R2, even though it's kind of like confusing at first. You're doing all this for other networks, all right, for other routers. All right, so IP DHCP pool, and the pool name is R1 LAN, capital R1 dash capital LAN. All right, let me make sure I type that right. All right, and now we're going to tell it network 192.168.10.0. Whoops. 255.255.255.0. That's our .10.0 network. All right, we're telling it that's the same thing as a \24 CIDR. All right, we told it use that network. All right, and then it only exclude whatever we told it up here to exclude. All right, now we got to tell it, okay, our default router is 192.168.10.0. 10.1. All right. Let me see if I can mouse over this. Whoops. And you guys can see it's 10.1, 192.168.10.1. So that's our default gateway. All right, let me get back to this R2. All right, then also the DNS server, which is sitting over here on the 20.0 network, we're going to tell it DNS. We're going to tell it where it is. DNS server 192.168.20.254. All right. So let's see. Create a DHCP pool on R2 for the R3 LAN. Okay. So DNS server is going to stay the same. Network's going to be 30s. Default router is going to be 30.1 instead of 10.1. All right. And then we'll name it DHCP pool R3 LAN. All right, so DHCP pool and oh, so let me do it from there. Because I'm already in DHCP config. Well, let's see. 3 LAN. So it's going to be that. Yep, let me do it. All right. So that's the LAN name, or the pool name, R3 LAN. All right, now we want to do the same thing we just did. And I'm up arrowing, so I don't have to type this in and make a mistake by accident. All right, 30.0. All right, 255.255.255.0. All right, there's our network of possible addresses. All right, default router is going to be a 30.1. And if we want to make sure, .1 is right there. All right, so no, that's right. All right, DNS server is going to be the same. It's not going to change. All right. So there's my 2 networks set up in my pools. My pools, my excluded addresses. All right. So we've done that. We created a DHCP pool named that. And everything it told us to do, all right, I referred to the addressing table up here. Double check, triple check. If you think it's wrong, don't try to type in something that doesn't work. All right, so configure R1 and R3 as DHCP relay agents. So the reason we want to do that is we're not setting up DHCP on those routers. We're going to put everything on the edge router, which is R2, all right, and have it look to R2 for the for that information for our local network. All right. Configure router 1 and router 3 as DHCP relay agent. For DHCP clients to obtain an address from a server on a different LAN segment, the interface that the clients are attached to must include a helper address pointing to the DHCP server. In this case, the hosts on the LAN that are attached to R1 and R3 will accept the DHCP server that is configured on R2. The IP addresses of the R2 serial interfaces that are attached to R1 and R3 are used as helper addresses. All right, I'll read that again. The IP addresses of R2 serial interfaces that are attached to R1 and R3 are used as the helper addresses. Okay, DHCP traffic from the hosts on the R1 and R3 LANs will be forwarded to these addresses and processed by the DHCP server that is configured on R2. Okay, so if we look right here, we know, all right, that's the helper address that it's supposed to be looking for. But from what that told me in that paragraph is that should be That's R1, so that should be this interface. All right. Let's look up here. Router 2. All right, serial 000 is right there. So that should be our helper IP address. Does that make sense? Let's make sure it makes sense. 10.1.1.2. Sorry, it's coughing. All right, so that's right. So look to that address when I need to get DHCP addressing. Okay, so R1. The big thing is easy to overlook. Make sure you're on your correct router. R2's up there, R1's down here. All right, so enable configure terminal. All right, so interface gigabit 00, and that's right here. All right, that's my gigabit 00. I'm going to tell it IP helper address is 10.1.1.2. Okay. All right, so now it knows to look for that interface, to that interface. All right, so configure the helper address for the LAN interface on R3. So if we leave this up here, do R3s, we can see what we did and duplicate a lot of it. Enable configure terminal. All right, let's not go crazy though. Let's look at R3. All right, so interface. Let me mouse over these. All right, so, and what this is saying, interface gigabit 00, which is going down on R1, when it needs IP addresses, it's going to go up here and look on this interface. All right, so we need to do gigabit 00 again, and then tell it, look at this interface. Or IP address, rather. The IP address that's assigned to that interface. All right. Let's do R3. We're at the global config already. Interface gigabit 00. All right, IP helper. And that's serial 001 on R2. Or I'm sorry, serial 001 on R2. 10.2.2.2. 2.2.2. Whoops, man, had too much coffee. All right, so now it should be looking. Anybody on here, look up here for IP addresses. All right, what else do we get? All right, so we set the relay agent for R1 and then R2. Configure host to receive IP addressing information from DHCP. This shouldn't be that bad. Just go down here, PC1, click IP configuration, DHCP. If you sit and let it work for a second, it assigned 192.168.10.11. That should be our first non-excluded address. So 10.10 was our last excluded address. That's our first non-excluded address. So we're good. All right. DNS server information, default gateway, subnet mask, all good. All right, let's go to PC2. All right, click DHCP. All right, 30.11, that sounds right. We're on 30 network. We excluded the first 10 addresses. That makes sense. Default gateway up there. That makes sense. Same DNS server as is the case for 10.0 network. That's fine. All right. So we're looking good so far. All right, configure a router as a DHCP client. If you see right here, that's what I just looked at. Verify that the hosts have received their addresses from the correct DHCP pools. Because if they didn't, you made a mistake. All right, configure a router as a DHCP client. Just as the PC is able to receive a IP version 4 address from the server, a router interface has the ability to do the same. Router R2 needs to be configured to receive addressing for the ISP. So that interface needs an address from this ISP out here somewhere. All right. So click on R2. We're in DHCP config. Let's exit out of that. All right. Interface. Keep it 01. IP address DHCP. All right. No shutdown. We're turning it on. All right, it just turned on. We have a green triangle and it's still converging. All right. So let's see. Use Packet Tracer's fast forward time feature to speed up the process. All right. So right here, looks like a fast forward button. All right. All right. So we're converged. All right. Use the show IP interface brief command to verify that R2 has received an IP address from DHCP. All right. You're gonna get these errors anyways because you got EIGRP running. But let's exit out of that. Show IP interface. Whoops. That's not gonna work. Let's exit. Show IP interfaces. Our interface brief. All right, so gigabit 01 has been assigned that address. 209.65, 200, 231. All right, so that's fine. All right, then go over here and R2. We're going to show IP DHCP bindings or binding. All right. And what that's showing you now is, all right, somebody's assigned this address, this IP address, this is their MAC address, and same thing over here. All right. If you're on your home router and you look at your IP addresses, and you can tell by the hardware address who that is. If you have a bunch of extra people on your, your Wi-Fi or your wired home router, something's up. All right. So that shows you who's on there. They don't name it IP DHCP binding, but that's just show people on my network. All right. So now we want to verify that PC1 and PC2 can ping all other devices. All right. Well, the farthest device I can see is ping. Well, let's ping this address on R2's interface. 209.165.200. All right, sorry, I had to pause it for a second. People email me. All right, 209.165.200.231. All right, I can ping that. And I wonder if I can ping. and that's actually that 209, 165, 202. So see, those are on separate networks too than this network. All right, and that's it. You can ping everything else, but yeah, pretty much that shows that it's working. Let me go here. I'll do the same thing. I'll ping cisco.com. It'll take a minute to resolve that name to the IP address. First ICMP packet times out. All right, there's that network. So more than likely these are on the same network because 157.158. All right, good to go. All right, thanks for watching. I know that took a little bit of time to get through, but that's one of those things that you will be setting up a lot probably, and you just gotta, take it step by step. But just understand that that's what's happening. You're setting up what you don't want them to assign IP addresses, what devices, servers, router interfaces, SVI interfaces on a switch, things like that. Then you actually set up your network. All right. So exclude. And I believe I've done this backward. I've done it the opposite way too. I set up my network first, and then I'll go through there and exclude IP addresses. It's good to do this first though, because if you do that, if you do this, you might forget to exclude anything, and then it just assigns. It starts at 10.1 and assigns all the way up to 254. All right. So you have a bunch of duplicate IP addresses on your network. All right, that's it. Thanks for watching. Oh, also in this, submit the your results. Should show your name. Obviously, if you have any errors in there, fix those. And then actually the packet tracer file. Actually, let me get back to this. Close. All right. So PKA file, screenshot of this that shows that. Make sure you logged in as you when you first log into the packet tracer, so it shows your name under check results. All right, not guessed. And that's it. There's no questions on here, so don't have to submit the Word document. All right, and that's it. Thanks for watching.